Hi, my name is Brad with Midwest CNC. Today we are going to finish up our CNC conversion of the Harbor Freight X2 mini mill. In the last video, I dismantled and cleaned the mini mill, getting it ready for the conversion that we are going to do in this video. Today we are going to install the Z, the Y, and the X axis. We are going to start off by taking the large 12mm bolt that is in our ball nut block that came with our CNC Fusion and sticking it through this hole. This is where the pinion went when the mill was in manual mode. Now I moved the handle down to make room for the ball nut block that came with the CNC Fusion. However, once I try to put the block in place, I find that this must be removed entirely. Make sure the limit block is holding everything in place. I put some Loctite on this 12mm screw so that it will not wiggle loose later on, as this is going to be a pain to get at once we lower the head back down the vertical column. Now we're going to use the 12mm screw that came with the kit to secure the ball nut block from the inside of the spindle head. Just snug up all the screws. Once we get the other two screws in the block from the other side, we will tighten this down. Now, we need to take off the zip tie that is keeping the ball nut from coming off the ball screw and spilling all the bearings out. I'm just going to cut it off and then thread the screw up by hand so that the screw can clear the limit block. Now that the screw is above the limit block, we can now put in the two 5mm screws that we took off the fine feed when we disassembled the mill. Once we have those started, we can go ahead and tighten down the ball nut in the back as well as the two front screws. Next, we need to lower the head all the way down. To do that, we need to loosen the limit block while holding the head and gently lower it down. You may damage your mill if you just let it drop. We can now lower the Z-axis motor mount down so that the middle hole shown here lines up with the Z bumper hole. Using the screw from the bumper, we will want to tighten down this screw and run the Z-axis up and down by hand to check to see if the Z-axis is going up and down without binding. Now I'm going to take off my motor so that I can drill the two holes that we're going to need to drill and tap in the vertical column. Once you get the first hole drilled with a 5mm bit, you'll want to tap the holes with a 6mm tap. Now that you have one of the bolts drilled and tapped, it would be a good time to put in the bolt and run the Z-axis up and down a couple more times to make sure that it is not binding. If everything went well, you're now ready to drill and tap the second screw. If you do not want to drill and tap the holes, you could also opt to drill a 1/4-inch hole and use the nut provided with your kit. I opted to drill and tap the holes and then attach the nut in the back. Now I'm going to reattach the motor and we are ready to move on to the Y-axis. The Y-axis. First, the Y-axis motor mount will come pre-assembled and look like this. We are going to need to disassemble it so that you can feed the in attached to the Spider Lovejoy connector through the hole that the Y-axis feed screw was attached to previously. I'm dismantling the kit all the way down. Because I have dismantled all of the Y-axis, I can now attach the aluminum enclosure without taking my Allen wrench off of the bolt. Be sure the bearing that is shown here is in place before you tighten down the aluminum enclosure. With the mill on its back, you'll be able to push the Y-axis saddle back as far as you can towards the vertical column. Now, feed the ball screw through the feed screw hole on your mill's base, like so, and insert the aluminum ball nut mount into the slot on the saddle that held the brass nut we took off earlier. Try to get it centered and snug down the locking screw. We are now ready to put on the second bearing and secure the two nuts that lock everything in place. Go ahead and put the first half of the Spider Lovejoy connector in place and tighten it down. I ended up using the spider connector to hold the ball screw in place while I tightened down the nut. You can now place the rubber end on the coupler and secure the motor mounting bracket. We are now ready to attach the stepper motor to the motor mounting bracket of the y-axis. Be mindful to attach the motor to the mounting plate so that the wires will be routed whatever direction you wish. Finally, reattach the two rubber guards using the Phillips screws that came with them. And now we'll be ready for the x-axis. The x-axis. We can now put in the gib screws, however we need to leave them loose. Install the x-axis ball screw with the ball screw on the right side of the mill. Slide the table on the saddle and place in the gib. The table should now have the ball screw sticking out on the right-hand side. Take the original thrust bearing plate that we recovered from the mill disassembly and put it on the ball screw. Put the locking collar onto the end of the ball screw and push it up against the thresh bearing. Now slide the table against the thresh bearing plate and tighten it in place with the two 6mm cap screws. Now we need to install the second thrust bearing plate and the two nuts to secure this side of the table. Install the x-axis mount on the left-hand side of the table. Once the motor mount is secure, remove the 4 screws that you will use to attach the stepper motor to the mounting plate. Place the rubber center inside the spider coupler. Then attach the stepper motor to the motor mount, making sure that the wires are in the direction you want to route them. And you're ready to snug up the screws that held the original brass nut in place. Now you can try to wiggle the mini mill table and see if you need to tighten up any of the gibs. We are now ready to set the steps per unit. Move your x-axis so that the finger points at 0. You now want to click the Settings tab in Mach 3. At the bottom you will find a button that says Set Steps per Unit. Click that button and Mach 3 will ask you which axis would you like to calibrate. Select the x-axis. Mach 3 will ask how far would you like the x-axis to move. Select 1 inch if you configured Mach 3 to read inches, or 25.4 if you're setting Mach 3 up in millimeters. Hit OK, and Mach 3 should now move about 1 inch. Mach 3 will ask you, how far did X move? Put in how far it really moved. In my case, it was 1 inch. Mach 3 will now calculate how many steps per unit it needs to use to get to 1 inch. Accept what it decides. We will now want to repeat this process for the z-axis. Y does not have a gauge on it, so I just copied the x-axis settings. Now, this will get us very close on the steps per unit. To get closer, you will use a dial test indicator, like so. Attach a parallel plate to your table and measure the distance it moves in 1/1000ths of an inch. Setting up the homing switches. What are homing switches and why do I want them? In short, homing switches will allow your computer to find the 0 point on your mill. This will also allow you to turn on soft limits so that the mill does not slam into an end stop. You will be able to hit the Ref All Home button and the mill will automatically move to its home and zero out the Z, the Y, and the X in that order. So, to set up the homing switches, you will need to go under Ports and Pins and turn on X Home, Y Home, and Z Home. You need to use the ports and pins that you wired your switch to the controller with. Make sure that Active Low is checked and hit OK. You want Active Low unchecked because it is a safer feature. If a wire breaks on your switch, it will automatically throw an error in Mach 3. If you didn't, the mill will keep trying to reach its home until you stop it. Next, under Homing and Soft Limits, make sure that Auto Zero is turned on. You can come back here later and play with your soft minimums and soft maximums so that your mill does not move too far. I have mounted my switches here: the Z, the Y, the X. Now let's watch them auto-zero the mill. The axis will move forward till it trips the switch, and then it will move back far enough to get off the switch. It will call this point 0. I hope that this video has been helpful to you, and if you have any questions or would like to see any other info, let me know.